The deepest hole we can't dig is a lie. The sound beneath the earth. They said the microphones picked up screaming, raw, endless, inhuman. 1,000 voices rising through miles of steel and stone. Headlines raced across the world. Soviets drill too deep. Discover hell. People claimed to have heard the tapes themselves, souls wailing in eternal fire. But the truth, as always, was stranger. Because those sounds, those impossible noises were real. Only they weren't cries from the damned. They were the voice of the earth itself, echoing from a place no machine had ever touched. In the early 199s, tabloids from Finland to United States ran the same headline: Soviets drill too deep. Hear the damned. It was irresistible, a Cold War experiment gone wrong, a story that blended science and nightmare. The legend claimed microphones were lowered into a hole so deep it broke through the crust of the planet, and what came out could never be explained. Radio hosts replayed the supposed recordings, a distorted mix of heat hiss, crackling static, and those haunting screams. People believed it because, on some level, they wanted to. They wanted to think we touched something forbidden. In the real story, there were no demons waiting, just silence. Silence so heavy it felt alive. Then, when the instruments came back to life, what they revealed didn't fit any rule the scientists knew. The truth beneath the myth wasn't supernatural. It was scientific and somehow more unsettling, because it shattered everything we thought we understood about the planet beneath our feet. To understand how this myth was born, we have to go back to 197. Back to the Arctic Circle, on a lonely stretch of Russian tundra near the town of Zapolyarny. A place where winter lasts 9 months, where wind whips across barren rock that gleams in the midnight sun. Here, a group of Soviet geologists arrived with cranes, drill towers, and an audacious goal: to reach the Earth's mantle. They called it the Kola Superdeep Borehole. On maps, just SG3. But among scientists, it was whispered as something close to madness, a dream to touch the unseeable. It began as a matter of knowledge, but it carried the pulse of Cold War pride. The Americans had gone up to the moon, and the Soviets wanted to go down. Where the U.S. had Project Moho, an attempt to drill beneath the Pacific Ocean, the USSR would pierce continental crust itself. Geology as geopolitical theater. They said they were going to map the planet's soul. Every meter drilled was a tiny victory, a deeper act of faith and reason. For years, the project felt unstoppable. The drill chewed through rocks older than life itself, spiraling down through the planet's forgotten history. But the lower they went, the stranger the world became. Instruments blinked out, readings contradicted one another, and heat began to surge faster than the math allowed. By 12 kilometers, the Earth had stopped obeying science and started writing its own rules. And that's where the myth began to form. When sensors started detecting noises, when pressure flares roared through narrow shafts, the stories started writing themselves. Reporters fabricated sound tapes. Preachers claimed it was proof of damnation. People wanted something dramatic enough to explain an effort that seemed to defy reason itself. But here's the truth. The screams were seismic echoes, pressure waves ricocheting through fractured stone and molten seams. The hell they heard wasn't religious, it was geological, the raw physics of stress made audible. Yet behind those tremors was something stranger, evidence that the planet's heart didn't look anything like the tidy diagrams in our textbooks. The deeper they drilled, the more apparent it became humanity had no idea what this planet truly was. Every meter was an act of faith against ignorance, and ignorance fought back. At 12 kilometers, they'd hit the boundary, not of hell, but of understanding. The Kola Borehole wasn't a descent into the underworld. It was a descent in the mystery. And at the bottom, there was no fire, no abyss, just proof. Proof that even now, after satellites and supercomputers, the Earth remains an alien world hiding beneath our own. A stranger we live on, but still barely know. Section 1. The Race to the Core. By the early 197s, the planet had become a scoreboard. Everything was competition. Who could fly higher, build faster, go deeper. The Americans had demolished the frontier of space by planting footprints on the moon. The Soviets wanted something new, something even the stars couldn't match. They'd go the other direction. Not upward, but inward. Straight into the heart of the Earth. The logic was both absurd and bold. If space was infinite, so was depth. The deeper you drilled, the closer you got to the planet's creation story. To the oldest rock, the purest heat, Maybe even the place where the surface first hardened out of molten chaos 4.5 billion years ago. Beneath the Arctic tundra, the Kola Peninsula became a launch pad for a different kind of exploration. No oxygen tanks, no rocket fuel, just drills, patience, and an almost religious faith and curiosity. 2 continents away, the U.S. was chasing the same dream. Their project, called Borehole, was supposed to reach what scientists called the Borehole, the theoretical line that divides the crust from the mantle. They picked the Pacific Ocean because under the sea, Earth's outer shell was thinner. Maybe they could cheat depth by starting lower. For a while, it worked. They drilled through water nearly 4 kilometers deep and bit into oceanic crust. It was working science fiction. But the project died in bureaucracy before the drill could touch anything profound. Funding collapsed, departments fought over jurisdiction, and the journey to the mantle became a footnote. The Soviets saw that failure as an opening. They were proud of steel, of endurance, of sacrifice. If the Americans could break the sound barrier, surely Soviet hands could break the planet's shell. The Kola Superdeep Borehole wasn't publicity, at least not mainly. It was obsession. Scientists wanted data, the Politburo wanted prestige, and the Arctic was silent enough for both. Zapolyarny was no one's idea of paradise, a mining town on the edge of the Arctic Circle, closer to the North Pole than to Moscow, surrounded by endless rocks sprayed with frost even in July. The place was so remote that radio contact sometimes lagged. Wind rattled the steel rig day and night. Workers described it like living at the end of the world, a gray horizon in every direction, a sky that never fully darkened in summer and never fully brightened in winter. Yet in that nothingness, they built something colossal. A spindly lattice tower rose from the tundra, holding the weight of millions of meters of steel tubing. At its base gleamed a cluster of small prefab huts, living quarters, labs, drilling control rooms. Beneath them, the ground trembled all day from the rotors spinning downward, eating through the crust at a few meters per day. Every so often, the drillers would pull up a core, a cylinder of rock from miles below. These samples were older than any mountain chain, some more than 2 billion years. They contained crystals the size of grains of sand, pressed together by unimaginable pressure, each layer a frozen second of Earth's original heartbeat. To the geologists on site, it was like archaeology in deep time. Some whispered that touching those rocks felt wrong, sacred even. They were never meant to see daylight again. At first, everything looked like victory. Machines performed, the drilling fluids held pressure, and Soviet engineers bragged that nothing could stop them. The Kola project became a showcase of communist confidence. Articles in Pravda called it a conquest of the internal cosmos. Just as the space program conquered the heavens, this would map the depths. Television crews filmed heroic workers covered in gray mud, smiling under banners of red and gold. It was propaganda with genuine wonder behind it. A decade in, they had already broken the world record for depth. Each milestone came with champagne and quiet panic. The deeper they went, the more unpredictable the readings became. Seismic surveys stopped matching their core data. What the instruments claimed to see below didn't resemble what the drill actually hit. It was as if every 1,000 meters erased another assumption. By 1983, while most of the Soviet Empire was flexing missiles and cosmonauts, a small crew on the Kola Peninsula had done something stranger. They'd made a hole so deep the math couldn't follow. Behind their laboratory pride lay a creeping sense of dread, because the farther they pushed, the more the planet misbehaved. No one said it aloud, but inside the dormitory canteen, jokes turned dark. "We're drilling to find Lenin's secret subway." "No," someone would reply, "we're drilling to meet him in person." The laughter was nervous, hollow. You could feel it, an unspoken awareness that machinery and geology obeyed the same rule: both will revolt when pushed too far. The Arctic air carried a metallic tang from the drilling mud. Pipes moaned as they cooled in the polar night. Even during short breaks, the humming in the ground never stopped. The project had become alive in its own way, breathing, straining, vibrating, as if the Earth itself were resisting. It wasn't just science anymore, it was a philosophical experiment written in steel and sweat. How much of nature would reveal itself before shutting us out completely? The deeper they drilled, the slower progress became, inches per day, months lost replacing burnt-out bits. But no one wanted to stop. Stopping meant admitting there were boundaries. What made the Kola project terrifying wasn't the risk of collapse or heat. It was realizing that the unknown beneath was infinite. Each measurement broke another certainty, and every core sample whispered the same truth. The planet we stand on isn't stable or knowable, not even close. The drive to keep drilling wasn't just Soviet pride. It was human nature condensed into one whole. We can't stand limits. We can't resist mysteries. The scientists didn't want the glory. They wanted the answer that always sits 1 meter deeper. You could say that the real race was never against America. It was against the end of understanding itself. And as the rig kept turning, as steel bit against ancient rock, something else began to form, not a discovery, but a fracture. The deeper they went, the less reliable the world became. Maps blurred, logic trembled, and curiosity turned into confrontation. This was more than a journey into the Earth. It was a journey toward the collapsing edge of knowledge. Section 2, Machines Against the Earth. From the start, the mission looked like triumph written in metal. The Soviets had always believed machines could outthink the planet itself. Tractors for fields, reactors for rivers, rockets for the sky. Drills were just another extension of that faith. One more proof that humans were not bound by geology. The rig on the Kola Peninsula became a mechanical cathedral to that idea. 12 stories of humming steel, rotating down into rock older than life, chasing a silence no one had ever touched. Every rotation of the drill was a small victory. The control room smelled of hot oil and coolant, its walls plastered with analog gauges that trembled with every shift in torque. Operators monitored pressure screens where tiny flickers marked the drill bit's struggles against rock that hadn't moved in eons. For the first several kilometers, things worked beautifully. The bit bit back, so to speak. It chewed through granites and metamorphic layers like a mechanical predator, sending up powdered rock and shards of stranger things, mineral veins that glittered blue, crystals warped by ancient heat, fossilized grains that looked almost melted. At the heart of it all was the rotary system, the pride of Soviet engineering. In conventional rigs, the entire column of pipe rotated. Here, they inverted the concept. The bit itself spun, driven by pressurized drilling mud pushed through narrow channels. This meant the miles of pipe above could stay still, avoiding catastrophic torque. It was genius, a machine designed to ignore gravity and friction, to spin cleanly in an environment made to crush it. But every kilometer added new kinds of pressure, not just mechanical, but existential. By 10 kilometers, the bit had twisted through strata no one had names for. Temperatures climbed, mud thickened, and the vibrations coming through the drill line began to sound wrong. The geophysicists called it harmonic distortion, a polite way of saying that the noise coming from the hole didn't match the math. Sometimes it thumped like a heartbeat. Other times it howled, a low metallic groan that rattled loose bolts in the tower. Engineers joked it was the planet complaining about the intrusion. They doubled down. Reinforced tubing, new alloys flown in from Moscow, specialized grease that could survive a furnace. Each adjustment bought them another 100 meters, but also another failure. Drill bits melted, bearings warped. Once an entire meter-long chunk of pipe twisted itself like licorice and snapped clean in two. They dragged the remnants to the surface, still hot to the touch, and stare in disbelief. They were building miracles that lasted hours before the earth devoured them. Every setback was analyzed, recalculated, made heroic. Soviet reports called the borehole a laboratory of extremes. That was true, but not in the way they meant. Instruments jammed at unpredictable depths. Thermometers gave contradictory readings. Sometimes the sensors reported temperatures 50 degrees too high, sometimes too low. No one knew if the instruments were failing or if the crust itself was playing tricks. Either explanation was terrifying. The physical strain mirrored the psychological one. Drillers worked 12-hour rotations in perpetual twilight. In summer, the sun refused to set. In winter, it barely rose. The entire rig was isolated by storms that could last weeks. Supply trucks arrived late, sometimes half buried in snow. Communication with Murmansk was patchy. Within that isolation, the machine became their only constant companion. Men swore they heard its pulse even in their sleep. They described it as a kind of breathing, a rhythmic pressure you felt through your bones. Each time the rods were pulled for maintenance, the cores told another contradictory story. Instead of predictable granite layering, the geologists found complex metamorphic bands twisted like ropes. The samples smelled faintly of sulfur and wet stone. When cracked open, quartz veins glittered in a way that suggested more than heat. It suggested motion. The deeper layers looked disturbed, churned, as if the crust itself had been kneaded like dough. It didn't match any model. That didn't stop them. The logic of the age was simple. If it resists, build harder machines. At the top of the tower, a red light blinked for rotation, a sound that became the daily heartbeat of the camp. The deeper they went, the thinner the line between equipment and environment became. You couldn't tell if the machine was fighting the earth or becoming a part of it. Bolts loosened themselves. The ground near the rig began to tremble faintly, a kind of sympathetic vibration transmitted from the hole. Locals miles away reported hearing low booms rolling under their feet like distant thunder. Officially, it was dismissed as wind across the tundra. Unofficially, some of the team thought the Earth was answering back. Scientists who had once spoken like explorers now whispered like priests. Every calibration error, every unexpected data point hinted at something neither human nor mechanical, some rhythm buried miles below, older than all tectonic maps. Meanwhile, Moscow issued proud communiques. Technological progress continues at Kola, but in the logbooks the notes grew desperate. Bit replaced. Bearings melted. Temperature off scale. Mud pressure unpredictable. The elegant system had become a guessing game against forces no one could predict. Each meter gained came at the price of broken machinery and sanity. The engineers started giving the drill bits nicknames: Gagarin, Sputnik, Victory, as if naming them could protect them. None lasted long. The deeper ones went, the stranger the failures became. Motors seized without cause. Lubricants evaporated. Once, the entire control console flickered for 20 seconds, showing data from shallower levels, then resumed as if nothing had happened. The scientists blamed magnetic noise. No one truly believed that explanation. They weren't drilling just to fill graphs anymore. It became personal, a test of endurance between human invention and the weight of the world. The pipe extended down like a tether to something both magnificent and hostile. When it moved, the entire rig shuddered like a living thing, groaning at the effort of exchanging secrets with a planet that didn't consent. By late 1982, progress slowed to centimeters per day. Money kept flowing, but patience thinned. The control room was littered with charts no one trusted. Somewhere around that time, a geologist wrote in his notebook, "Each new meter subtracts another certainty." He meant it literally. The readings contradicted one another so often they started calling their own experiments paradoxes. When a piece of failed drill bit was hauled up, fused into a shape no human alloy could hold, one of the metallurgists simply stared at it and muttered, "It's not supposed to melt like this." Not here. The very thing that once felt like triumph, a machine conquering Earth, had turned into an act of stubbornness. They weren't learning anymore, they were insisting. No one wanted to be the one to say stop. Because stopping meant admitting there was something below human reach, and the entire project was built on the denial of that idea. Those final months before the first major stall felt like war. The drillers fought friction, pressure, temperature, and the invisible line between science and madness. Some said they saw steam rise from the drill head, glowing faintly in the midnight sun. Others swore you could hear the metal singing. It wasn't music. It was stress, vibration, and resistance, merging into a chorus that felt almost alive. And somewhere beneath all that, the data began to bend. Seismic readings lost coherence. Thermal gradients climbed beyond predicted curves. The deeper they pushed, the more it looked as if the crust itself was folding inward around the bit, refusing entry. They didn't know it yet, but they were mining the limits of knowledge itself. The instruments weren't breaking, reality was. That was the final revelation of the machines. They weren't built to conquer the Earth, but to show where the conquest ends. The Kola Borehole wasn't reaching the planet's heart, it was reaching humanity's. And soon, the numbers would stop making sense entirely. Section 3. The first paradox. For decades, Earth scientists have relied on one assumption, that the crust followed an orderly pattern. From the surface down, there would be granite, then a sharp change, a boundary called the Conrad discontinuity, and finally basalt. Seismic waves around the world had drawn a clean picture of it. You could almost plot it like a neat layer cake beneath every continent. The Kola drilling team carried that expectation into their work like gospel. But around 7 kilometers down, something went missing. The seismic reflections they expected, those crisp echoes from the granite to basalt switch, never arrived. Sensors that should have spiked stayed flat. The data suggested the drill was still in granite, long past where basalt was supposed to begin. At first, they assumed equipment error. They recalibrated, checked magnetometers, switched thermocouples. Same result. The echoes refused to appear. When the rock cores returned to the surface, the situation became impossible to ignore. Instead of dark basalt, the cores showed more of the same metamorphosed granitic rock, granite that had endured absurd heat and pressure, until it had twisted on itself, contorted into something halfway between crystal and clay. The supposed crust-mantle transition had evaporated. The dividing line that every geology textbook showed simply wasn't there. In the Moscow Institute's early reports caused disbelief. If seismic data could be trusted at Kola, how much else of Earth's known structure depended on illusions? Universities had built careers on those seismic models, mathematical ghosts of the planet's interior. And now the deepest man-made wound in the Earth said they were wrong. At the Kola site, reactions swung from exhilaration to dread. The scientists weren't just seeing deeper, they were unmaking certainty. One geophysicist scrawled across his notes, "The crust refuses order." For the Soviets, who prized conformity even in nature, it was a strangely poetic revolt. The planet had decided it would not fit the theory. Worse still, some of the seismic instruments began registering double signals, faint echoes arriving milliseconds apart. No one could locate their source. If the rocks were homogeneous granite, sound waves shouldn't scatter that way. That's when a new hypothesis surfaced. Maybe the crust wasn't uniform at all. Perhaps ancient tectonic scars ran like invisible veins, duplicating signals as they bounced through zones of crushed minerals. Each echo was a hint of an older catastrophe frozen in stone. Kola had drilled straight into the fossil bone of an event billions of years gone. The implications were brutal. For the first time, seismic interpretation, the foundation of modern geology, looked fragile. Across the scientific community, papers rippled out with cautious titles, reevaluation of continental structure in light of Kola data. But inside Kola, the tone wasn't cautious, it was personal. One researcher later admitted it felt like discovering the alphabet was wrong halfway through a book you'd already written. The paradox went beyond composition. Chemical analyses of the deeper samples found unexpected mineral arrangements, mica and amphibole crystals, aligned in ways that implied fluid motion long after the rock should have solidified. The deeper layers weren't dead, they'd moved, flowed even. The crust wasn't a solid lid, but a slow, creeping fabric. Geological solid ground was metaphor, not fact. That realization shook more than scientists. The political overseers had invested in this project as proof of control, an endpoint of knowledge carved downward by force of technology. Instead, it was exposing disorder. Reports reached Moscow couched in euphemism, unexpected transitions in rock type, possible local anomaly. But every engineer at Kola knew it wasn't local. The anomaly was us. Our measurements, our models, the arrogance that the planet worked like a machine. The paradox spread like a crack through their morale. Temperature readings spiked without warning. Pressure swung beyond tolerances. The equipment was still reliable, but reality underneath it wasn't consistent. When they drilled another kilometer, readings that should have shown increasing density instead dropped. By all logic, the lower rocks were lighter than the ones above them. Impossible. One geochemist muttered what many felt. We're not measuring Earth anymore, but something inside it. Each night they gathered in the lab, analyzing fresh cores under harsh fluorescent light. Those samples glittered with minerals formed at pressures far higher than 12 kilometers depth. It meant that the layers below them might be even stranger. Compressed, folded back upward, as if the crust had once tried to swallow itself. Textbooks had imagined a polite boundary between crust and mantle. Kola showed it was more like a storm frozen in stone. Back in the West, seismic reanalysis began showing hints of the same irregularities. Scientists re-examined data from Scandinavia, India, even California. They found discrepancies they'd ignored before, chalked up to instrument error. It wasn't error. It was complexity. The planet wasn't a simple sphere of layers. It was patchwork. Earth had memory, and that memory distorted every attempt to read it. At Kola, meanwhile, the humor evaporated. Technicians started using the word mirage for readings that flickered and vanished. Maps of subsurface density were peppered with question marks. The borehole that had started as a triumph of precision was now a lesson in humility. The more information they captured, the less of it agreed with itself. One afternoon, after days of silence from the lower sensors, they finally received seismic pulses again. Weak, delayed, almost hesitant. The waveform wasn't smooth. It looked fractured, like language half-spoken. An analyst compared it to an echo recorded through shattered glass. That trace became famous in internal circles. They called it the first paradox, a simple experiment whose result couldn't exist. Some within the project dreamed up wild explanations, pockets of gas, subterranean fluids, crystalline faults. None fit perfectly. Others grew philosophical, whispering that maybe they'd reached a depth where measurement itself lost meaning, that between pressure and heat, the rock no longer behaved like matter should. Nothing in their equations could predict it, because equations were written for the calm, not the chaotic. Slowly an idea settled over them, that knowledge didn't expand linearly downward. There was a horizon, like the one in physics, a boundary beyond which observation collapses. At around 7 kilometers, they felt they touched that boundary once. They had proven something naive yet profound, that the act of seeking could dismantle the scaffolding built to understand. Still, they kept drilling. The paradox haunted them, but curiosity weighed more than fear. The same discovery that wrecked the model also made the mission irresistible. If the crust could rewrite the rules once, what waited below might erase them entirely. When the next kilometer gave way to unstable signals and instruments that behaved like ghosts, no one proposed stopping. The Kola team had already crossed from research into obsession. Somewhere beneath them, deep within that silence, the planet was whispering a language no one knew how to translate. And as they prepared new bits, new pressure seals, new excuses for funding, they carried one truth like a hidden prayer. The first paradox wasn't a mistake. It was an invitation to keep falling and see how many more certainties would break before they did. Section 4. The Hell of Heat. What came next was heat, more than any calculation had dared predict. The model said that at 12 kilometers, temperatures should hover around 100 degrees Celsius, maybe a little higher. That seemed manageable. Steel could take that. Instruments could take that. But when thermocouples finally stabilized at depth, the reading was closer to 180. That number looked like a typo. Then a second instrument confirmed it. The borehole wasn't warm, it was furious. The first sign of trouble came when drilling mud began to hiss. Fluids pumped down to cool the bit came back up slightly fizzing. Its viscosity changed. Samples extracted at depth sizzled in contact with the Arctic air, releasing thin curls of vapor that smelled metallic. Within days, the drill head started deforming. It wasn't snapping or shattering, it was softening. By all physics of metallurgy, that wasn't supposed to happen at those pressures. But down there, laws failed politely and then stopped showing up. One engineer described watching a freshly pulled bit. Its edges shimmered, glowed faintly, then sagged like wax. They dunked it in snow to cool it, and the snow melted instantly. The team measured the returning mud temperature at 80 degrees. That was the fluid meant for cooling. It came back scalding. At that point, they realized the Earth itself had turned hostile. The deeper rock wasn't brittle anymore. The drillers expected cracks, fractures, explosions of dust. Instead, they found pliability. The rock around the pit behaved like dense clay, squeezing inward slowly, closing behind the shaft so that each time they paused drilling, the borehole began healing itself. The word that surfaced in the reports was plastic. The crust wasn't static, it flowed. In the control cabin, gauges began to twitch erratically. Torque fluctuations that once indicated small variations now jumped whole orders. Pressure sensors sounded alarms without obvious cause. It wasn't equipment failure, it was the environment changing second by second. The operators could almost feel the hole breathe beneath them, a soft surge as heat expanded trapped fluids, then contraction as it cooled. The planet was flexing around their intrusion. They tried every engineering trick available. New drilling fluids with higher boiling points. More robust steel alloys. Thermal isolators. Nothing lasted. Electronics fizzed out after minutes. Insulation baked away. The scientists joked grimly about cooking their instruments in Earth's oven. Repairs became daily rituals. Rewire, replace, recalibrate, hope. For every meter gain, another sensor died. Then came an unnerving discovery. Even with active drilling suspended, temperature in the borehole kept rising. It was as if each rotation of the bit unlocked deeper heat that refused to dissipate. Thermal models predicted gentle gradients. Instead, Kola's gradient spiked violently. That suggested something fundamental about heat transfer in the crust was wrong, or that some internal mechanism was trapping energy. Both answers meant rewriting textbooks. Field reports grew more poetic as frustration deepened. One technician wrote, "The rock pulses." Another noted that gravity readings near the site began fluctuating ever so slightly during drilling periods. A few microgals difference, far too tiny to prove anything, but enough to make people wonder whether expansion of heated rock could distort measurements. Geologists spent long nights staring at cross-sections, trying to understand why heat built faster with depth than predicted. One theory blamed water. Maybe the fractured crust had trapped ancient fluids under immense pressure, turning them into superheated steam. Another theory said the thermal conductivity of the metamorphic granite changed dramatically under compression, channeling heat unevenly. None of it explained why every tool designed for hundreds of degrees failed at barely half that. The psychological toll mirrored the mechanical stress. 12-hour shifts became 12-hour standoffs with invisible fire. Workers emerged from the rig room flushed and trembling, as if they'd wrestled the planet. Sleep deprivation bred hallucinations of vibration through metal walls. Even off-duty, they said they felt it, the hum in the ground like heat-made sound. It wasn't supernatural. It was conduction, convection, expansion. But knowing the science didn't make the sensation less eerie. Progress shrank to centimeters. The borehole walls smoothed into a glassy surface, compacted by pressure. Attempts to reinforce them only made it worse. Injected cement boiled, cracked, then squeezed upward. The deeper they went, the faster the earth erased their work. When they tried to resume drilling after a brief mechanical pause, the bit jammed in place. It took 3 days to free it. The data recorded during that stall became infamous, oscillating temperatures seemingly climbing, falling, then climbing again as if the rock seat was alive. By that point, rumors circulated among the crew. Some swore that if you put your ear to the drill column during operation, you could hear low moaning noises. Rationally, everyone knew it was harmonic resonance from rotating steel. Emotionally, it sounded wrong, long, wavering, almost vocal. Those were the sounds that later fed the myths. Someone taped them for analysis, and once copied through degraded analog equipment, the result resembled human cries. That recording, traded later between radio hosts, became proof of the screams from hell. No one at Kola believed such nonsense, but they couldn't deny that what they heard unsettled them. Science was the new superstition, and it terrified just as thoroughly. When Moscow analysts reviewed the final month's data, they were stunned. The Kola temperature curve defied every geothermal model used in academia. Instead of stabilizing with depth, it bent sharply upward, implying that at 15 kilometers, the temperature would exceed 300 degrees beyond any known capability of drilling systems. In a single stroke, the project reached not the mantle, but the ceiling of human endurance. Inside the rig, the heat changed behavior in strange ways. Lubricants ran thin like water. Metal joints expanded so much that bolts refused to fit. Some mornings, ice crystals formed on the rig tower from Arctic wind, while the borehole directly beneath steamed like an exhalation. 2 climates meeting at one point, a frozen desert above, a furnace below. Eventually, the command came to halt operations. Officially, the reason was budget and technical reevaluation. Unofficially, the scientists had no path forward. Every method of extension risked losing the entire borehole to collapse or melt. As the last sections of tubing were pulled and sealed, the site felt less like a laboratory and more like a shrine. They had reached 12,262 meters, and at that depth the planet had answered in heat, not words. Standing beside the cap shaft, one senior geologist said quietly, "It feels like the ground is breathing through it." They didn't mean metaphorically. Residual convection kept faint waves of warmth rising through the metal. In the frigid air, it shimmered like mirage. The hole exhaled. Humanity inhaled wonder and defeat. For the team, this wasn't failure. It was revelation. The Earth had a defense mechanism, temperature itself. Beyond a certain depth, matter stops behaving as a solid and starts acting like memory, bending, reshaping, erasing intrusion. They hadn't just found limits of technology, they'd touched the physical form of uncertainty. Later analyses confirmed what the crew already sensed. At around 12 kilometers, rock transitions from brittle to ductile. It creases instead of cracks, like muscle rather than bone. That's why it tried to close around a bit. That's why temperatures rose uncontrollably. They had breached not a geological boundary, but a philosophical one, the point where the Earth refuses to remain predictable. When journalists later asked why they stopped, one engineer answered, because the planet melted our science. It sounded flippant, but it was literally true. Every calculation dissolved into that heat. As the Arctic night closed over the silent rig, the metal tower gleamed faintly under stars that never set. Beneath it, miles of instruments now frozen in inactivity led to a chamber of slow-moving stone, still warm, still healing. The Kola Superdeep Borehole was no longer a project. It was a scar. A reminder carved 12 kilometers deep that curiosity burns just as fiercely going downward as upward. The space race had left footprints on dust. The Earth race left nothing. The hole sealed itself, almost tenderly, as though the planet preferred silence. And up on the surface, the scientists stood in that silence, realizing the truth that would haunt every future drilling attempt. The Earth doesn't yield knowledge. It resists it. We didn't lose the technology or money. We lost the heat, the purest form of the unknown. The inferno wasn't mythic at all. It was geology defending its secrets. Section 5, Fossils in Hell. After all that chaos, heat, pressure, and deforming rock, the last thing anyone expected to find was life. Not living, not breathing, but proof that it had once existed where life should never have been. 6 to 7 kilometers down, cores from the intermediate depths revealed something on their surfaces that looked wrong in a way science loves. Clear, undeniable, impossible. When the first cylindrical samples were hauled up, coated in translucent drilling mud, nobody noticed anything unusual. The routine was simple: slice, catalog, photograph, archive. But under magnification back in the field lab, one petrographer stopped cold. Embedded in the metamorphic grains were oval-shaped, delicate outlines, sequences repeating like stamps. A few more slides later, the microscope showed entire structures, cell walls, ridges, even traces of once organic carbon. The samples were teeming with forms that looked biological. 24 species they would later identify, all dating to nearly 2 billion years ago. That number staggered the team. 2 billion years, back when oxygen barely existed in the atmosphere, long before multicellular organisms. Yet here were microfossils preserved inside crystalline rock, sealed beneath layers of mineral compression that should have destroyed everything. Scientists held the thin rock slices to fluorescent light and whispered profanity usually reserved for miracles. The fossils were found between thick veins of metamorphosed sediment, so crushed and heated that it seemed absurd anything recognizable could survive. And yet under thin film analysis, the cell outlines glowed faintly with traces of carbon and nitrogen. Those elements suggested biological origin, not random mineral growth. What terrified and thrilled them simultaneously was location. 7 kilometers deep is not supposed to contain remnants of surface life. Geological law said such layers should have recycled ages ago through tectonic subduction. Ocean sediments become mantle feedstock, melting and re-emerging as volcanic flows. Nothing should preserve fossils at those depths for billions of years unless part of the planet had stopped obeying recycling. That tiny discovery hinted that Earth's crust might not churn as efficiently as scientists believed. Pockets of ancient surface matter still rested untouched in the deep. As word spread through internal channels, disbelief rippled through Moscow's academies. Some claimed contamination, mud circulation could have dragged modern particles downward. The field team double-checked everything: sterilized containers, control samples, isotopic dating. The isotopes fit Precambrian timescales. The fossils were no modern intrusion. They'd been entombed before animals were even a concept. Out on the Arctic site, the revelation changed the mood. Where before there was frustration, now there was all tinged with dread. The Earth had not just fought them with heat, it had begun whispering its own history. An ancient black shell converted into metamorphic schist, the scientists found traces of the planet's first breath. To reach them, they had scorched through voids of hydrogen gas and plastic rock. surviving conditions that melted steel, only to expose ghosts of microbes, perfectly preserved. The questions multiplied faster than answers. How did such fragile forms endure pressures of 200 atmospheres and temperatures over 100 degrees? The organic shells were supposedly surrounded by a hydraulic lattice of mineralized silica that acted like armor. Still, those pressures should have crushed everything to dust. One geologist compared it to opening a lava lamp and finding snowflakes intact. As specialists from Leningrad arrived, they carried portable spectrometers and skepticism. Within days, skepticism turned into obsession. They confirmed layered coatings of carbon compounds, residues of once living cells. Each microfossil mirrored documented species from shallow marine sediments nearly 2 billion years old, back when photosynthetic bacteria had first started flooding the planet with oxygen. That oxygen is what gave Earth its rust-red iron beds and possibly turned these creatures to stone. The deeper implications stung. The Kola Borehole wasn't just penetrating ancient rock, it was pinning down the boundary between life and non-life. Somewhere along that descent, chemistry crossed back into biology. In layers hotter than boiling water, pieces of the biosphere had survived. And if they could persist there, buried beneath eons of pressure, maybe life was more tenacious and more widespread than believed. Some nights the scientists joked uneasily. "We dug to hell and found bacteria," one said. "Makes sense. Everything starts small." Others found themselves staring too long into microscopes, hypnotized by the delicate spirals of something that had lived and died before mountains formed. The fossils felt like eyes watching through time. News of life deep underground escaped the usual censorship loops. Western media caught fragments from international geological conferences and ran wild headlines: "Soviets find life in fiery abyss." Overnight, mythology returned. Rumors blurred science in fear. Some claimed the Kola team had discovered living organisms still rising under heat. Others suggested radiation mutated colonies. Reality was quieter but somehow stranger. Mere imprints of once living things, etched in rock where no ocean had touched for eons. Among younger researchers, one uncomfortable idea emerged. Perhaps those fossils weren't trapped relics, but representatives of an ancient biosphere still lurking deeper down. The microstructure seemed surprisingly undamaged, as though the process of preserving them happened fast, not over millions of years. What if microbial ecosystems once thrived kilometers below the surface, using geothermal energy instead of sunlight? Decades later, scientists would find such life around deep ocean vents and within crustal rocks. But at Kola, this theory sounded like heresy bordering on mysticism. And this discovery did something subtle. It blurred the frontier between geology and biology. For the first time, biologists found themselves consulting drilling engineers about the limits of temperature tolerance. If life's ghosts existed at 7 kilometers, maybe life itself could endure even deeper. Each new discussion turned the borehole into something cosmic, a stand-in for every unanswered question about habitability on other worlds. NASA and ESA archives show later that fragments of Kola data influenced astrobiology protocols. When searching Mars or Europa, scientists began considering that fossils might be locked not on the surface, but far beneath, inside rock grained by heat. Humanity's first window into life beyond sunlight came from that frigid Soviet shaft that accidentally reached what amounted to Earth's first tombstone. But in 1984, none of that was clear. All the team knew was that under a microscope lay evidence that the planet never fully cleans its history. The past, one researcher wrote in his log, is alive and waiting if you dig far enough. It sounded more like poetry than science, but that same sentiment found its way into Soviet journals months later under academic phrasing: evidence for preservation of biogenic microstructures at ultra-deep metamorphic depths. Translation: fossils in hell. Back at the drill site, the discovery became almost personal. Each time new cores surfaced, technicians held their breath, peering for additional traces: the curve of a cell wall, the lattice of filaments. They found plenty. Enough to suggest whole sheets of fossilized mats stretched deep in the crust. And every time more samples arrived, the air inside the cramped lab felt heavier, as though they were trespassing in sacred ground. This wasn't just geology. It was resurrection. But fascination carries consequences. The revelation revived the very rumor that had once embarrassed them. Warm tabloids fused two facts: the mythic screams from hell and the real fossils. and declared that Soviet scientists had discovered lost souls turned to stone. The researchers laughed, yet none denied the symbolic power. Earth's depths indeed held ghosts, just not the kind holy books described. These were ghosts of ecosystems, echoing across epochs we barely comprehend. Through microscopes, through rotting paper reports, the image became unforgettable. Microscopic fossils suspended in metamorphic glass, like constellations frozen in rock. Proof that even buried under unthinkable pressure, traces of life persist. When the site later cooled, long after drilling halted, one technician returned alone and described leaning against a sealed borehole cap, warming his hands from the faint rising air. He said it felt like the planet itself exhaling. Beneath that breath were remnants of everything that ever lived, condensed into dust, memory, and carbon, the inheritance of a world that refuses to stay dead. In the end, those fossils changed more than geology. They altered our measure of mystery. They reminded every scientist who touched them that the line between myth and science is often drawn by temperature and stubbornness. And as the laboratory lights dimmed on that Arctic plateau, it became clear why the discovery stirred so much awe. In trying to reach the mantle, humanity instead found its own origin story, written in cells that had outlived continents. The Earth wasn't hiding horrors in its depths. It was preserving history far longer and far deeper than we ever imagined. Section 6, the gases from below. They thought they'd reached the end of surprises, but then the Earth started whispering gas. In the weeks after the fossil discovery, every new core extraction came with faint hissing sounds when the pressure seals cracked open. At first, nobody cared. Gases are common in boreholes, remnants of trapped air or hydrocarbons. But these were different. The release was intense, almost violent, like opening a carbonated bottle the size of a mine. Vapor burst upward with a roar, strong enough to fog the laboratory windows despite the Arctic cold outside. The smell was metallic, sharp, something between ozone and wet stone. Within seconds, the lab filled with condensation that condensed into shimmering droplets on every surface. Someone measured the composition. That's when patterns began to fall apart again. The gas wasn't mostly methane or carbon dioxide as expected. It was hydrogen, nearly pure, over 15% concentration in some samples, more than 1,000 times higher than predicted. It came in pulses, surging from fractures in the deep core sections as if released from pockets under tremendous pressure. Hydrogen at that depth made no geological sense. There shouldn't be enough organic matter or water reactions to generate it, yet the sensors were clear. The Kola Borehole had tapped into some enormous reserve of primordial gas, hydrogen that might have been trapped since the planet's formation, sealed away for billions of years. In a single moment, the project pivoted from geology to something closer to planetary chemistry. The scientists weren't studying Earth's crust anymore. They were sampling its ancient breath. Technicians began collecting the venting clouds and steel cylinders. When exposed to air, small pops of flame ignited, blue and brief, like candles in the wind. The men laughed nervously and called them geological ghosts. It wasn't laughter from amusement. It was the only thing preventing panic. Nobody could shake the sense that the ground itself had started replying. Each gas composition test added to the absurdity. Alongside hydrogen came traces of helium, nitrogen, carbon dioxide, and, strangest of all, small amounts of methane and isotopic patterns that didn't match biological origins. Something deep below was cooking elements in ways no known thermal gradient explained. Every attempt to model the chemistry produced contradictions. Too much hydrogen for the pressure, too little carbon for the methane. The deeper explanation escaped them. At the surface rig, vent pipes sang with pressure, literally sang. When the wind passed over their openings, each pipe's vibration echoed through the metal scaffolding, forming eerie harmonics that rose and fell like distant voices. Combined with the constant rhythmic thrum of the drill tower's generator, the entire camp felt haunted by sound. Workers described hearing wailing on the night breeze. Eventually, someone joked they were the screams of the hole, a joke that newspapers later turned into a legend. Audio recordings made for study only magnified the unease. The low-frequency whooshing of gases filtered through kilometers of steel tubing sounded disturbingly human when sped up by equipment. Static bursts resembled overlapping voices. Radio interference produced tremolo effects, like chanting echoing from somewhere underfoot. By the time the recordings leaked to Western ears, they had become myth, proof of infernal noises beneath the earth. What began as pressure venting became tabloid damnation. Inside the camp, reality was less theatrical, but far stranger. The scientists knew they were witnessing a phenomenon barely documented, hydrogen gassing from metamorphic rock that should have been sealed solid. It meant the crust wasn't the inert shell textbooks claimed. It breathed, exchanging gases through microscopic fractures forged by heat and pressure. The planet was alive in its own mechanical way, exhaling the stuff of stars. Not everyone handled it well. During one maintenance shift, a pressure gauge blew and filled the control room with an invisible mist. Everyone evacuated as alarms screamed, fearing explosion. Later testing showed the gas concentration below ignition level, but the incident left psychological residue. Technicians began taping the vent seals with extra layers, even though it made no difference. They just wanted a barrier between themselves and whatever dreamlike mixture seeped from 12 kilometers down. Hydrogen wasn't the only mystery. Isotope analysis hinted that some gases were radiogenic, born from decay of elements deep in ancient rocks. Others seemed far younger, possibly diffused from water trapped miles below. The conclusion no one wanted to admit was that the crust was crisscrossed by hidden pathways connecting unthinkable depths to the surface. Trapped heat, minerals, gases, everything in motion, slowly trading places across geologic ages. The solid world was not solid at all. The drilling pressure differentials began fluctuating wildly, likely from these unseen gas movements. Every surge risked blowing the borehole's integrity. Each time that happened, crew members would hear a deep rumble traveling through the rig's frame, followed by the strange echoing moan they'd come to fear. It wasn't supernatural, just physics, a mix of resonance and vent release, but even the rational minds grew jittery. In nightly logs, the geologists in charge started adding small poetic lines between data tables, the Earth-sized. It breathes hydrogen. It remembers. No one mocked him. Everyone understood. Those phrases captured a feeling none of the quantitative data could. Standing next to the borehole felt like standing beside a colossal organism that occasionally murmured in its sleep. Soon the gases themselves began corroding the sensors. Instruments darkened, copper turned green. Even without combustion, hydrogen seeped into the metal lattice of pipes and made them brittle. Hydrogen embrittlement, a problem no one had predicted this deep. Every vent became a risk of fracture. Engineers tried swapping alloys, sealing joints, filling annular spaces with inert gas. Nothing could contain the slow, constant breathing of the Earth. As international awareness of the borehole grew, Western journalists searched for spectacle. They found it in those eerie hissing recordings. By the late 198s, evangelical radio shows in America replayed edited versions spliced with reverb and distortion, claiming they came from microphones lowered into hell. Soviet officials issued dry statements blaming faulty acoustic interpretations. The myth only flourished further. In a paradoxical twist, the scientists' legitimate data, the world's deepest hydrogen source, was overshadowed by stories of souls screaming underground. Privately, the team found the confusion fitting. They agreed the sounds did carry meaning, just not theological. Every moan was pressure discharge. Every tremor, the crust way of relieving built-up energy. To their trained ears, those noises weren't terror, they were information. Proof that the planet conversed in frequencies humans were barely able to translate. And yet, when you're standing alone by the rig at night in minus 30 degrees, listening to a faint resonance wafting up from a hole as deep as human ambition goes, logic can feel flimsy. The sound might not be voices, but it feels like communication. The thin Arctic air vibrates with the echo until you almost sense it forming syllables. It's easy to see why myth blooms in such places. The gases kept seeping long after drilling halted. Even years later, scientists visiting the sealed site reported soft bubbling under the metal lid, tiny pockets of hydrogen still finding pathways upward. Those invisible emissions were harmless yet hypnotic, a subtle proof the borehole remained alive. The Earth never stopped exhaling. For geochemists, the discovery became a cornerstone of a new idea, that the planet leaks hydrogen continuously through microscopic fractures, fueling hidden chemical ecosystems. For everyone else, the symbol endured as something simpler, the sound of the unknown breathing back. In truth, the so-called screams from hell weren't from beneath theology's abyss. They were from physics' edge. the point where pressure turns solid matter porous, where silence transforms into vibration. The tapes exaggerate, the legend lies. But standing on that frozen expanse, hearing the faint susurration under your boots, you could understand why the story survived. Because if you didn't know about gas laws or resonant frequencies, if you only heard that ancient sigh, you might think the world itself was trying to speak. And maybe in a way it was. Section 7. When Data Stops Making Sense. By 1987, the Kola Superdeep Borehole was no longer an engineering challenge, it was an existential one. The deeper they drilled, the less anything agreed with itself. Readouts contradicted their own baselines. Samples disobeyed chemistry. The planet, for lack of a better word, started to lie. Every morning, the geophysicists printed reams of graphs, temperature, density, seismic velocity, and by the afternoon, half of them were obsolete. The numbers refused consistency. Even at stable depths, measurements fluctuated like nervous handwriting. On Tuesdays, rock density increased. On Wednesdays, it thinned. Sometimes two instruments side by side would report opposite results. The Crust, one researcher's side, has decided to improvise. At first, everyone assumed calibration drift. They replaced sensors, recalibrated clocks, re-zeroed everything with obsessive precision. The inconsistencies grew worse. Graphs once tidy as heartbeats turned into tangled static. Seismic wave velocities, which should have risen smoothly with depth, started zigzagging unpredictably. Rock that should conduct vibrations faster suddenly dulled them, as if pockets of soft material interrupted the path. Yet coarse samples showed nothing unusual, only featureless metamorphic stone. The sound waves were bouncing off something that didn't appear to exist. In the canteen, the drillers began calling it drilling into chaos. They said it lightly, but no one laughed much anymore. The deeper data came in, the more uncertain they sounded about what Earth even meant. They'd been taught the crust behaved like a solid, measurable body. Now it looked more like a mirage shifting beneath observation. There were rumors of deeper anomalies, signals showing density decreases where pressure should create compaction. That hint alone terrified them. If true, sections of the crust could be riddled with cavities or lighter materials, unpredictable to stress modeling. A small misstep, a wrong assumption, and kilometers of rock might behave like fluid. Even a theoretical collapse at those conditions carried unimaginable energy. The telemetry team tried cross-checking with seismic tomography from other sources. The anomalies aligned with none of them. What science expected was a gentle gradient, granite giving way to heavier basalt, then the Mantle's slow convection currents. What Kola recorded looked more like fingerprints pressed into stone. Layers folding over themselves, diverging temperatures in neighboring samples, apparent shear zones that shouldn't exist without fault lines. It was as though the borehole had become an antenna detecting the planet's private turbulence. One evening, a young analyst left the monitoring station and scribbled in his log, "The instruments tell different truths depending on who listens first." It wasn't philosophy, it was pattern interference. They learned that even small routine disturbances altered measurements. Pumping fluids, adjusting drill torque, or temperature variation in the drilling line shifted readings dramatically. It was as if the crust behaved quantum-like at kilometer scales, observing it changed what it was. By now, even routine maintenance felt metaphysical. The control screens crackled with jitter. Analog dials pulsed irregularly. Charts looked like EKGs for a dying patient. When a sensor flatlined, no noise, no frequency, only straight silence, it meant the rock had become too plastic, too homogeneous to reflect signals. That silence unnerved them more than any anomaly. They called those zones shadow depths. The word spread through scientific channels, and soon geophysicists half a world away began reanalyzing old datasets. Patterns emerged. Pockets of low-velocity anomalies beneath stable continental crust, nowhere near subduction zones. Previously dismissed as noise, they now looked eerily similar to Cola's results. Maybe the crust wasn't a solid lid over the mantle. Maybe it was stitched together from ancient material that never mixed properly, like patchwork cloth melted halfway. From this realization came an early glimpse of what modern geoscience would call the Mantle paradox. Deep within the planet, some regions appeared chemically distinct, richer in silica or iron, proof that the mantle might be layered, not convecting as a single mass. If true, it broke decades of geophysical dogma. That convection blended everything below like soup, Instead, Kola hinted at a lumpy planet made of half-mixed errors. Inside the project, the paradox translated to panic. Models used to predict geothermal gradients, tectonic strength, even earthquake propagation suddenly looked suspect. Data from Kola didn't just fail to fit equations, it made the equations meaningless. Temperature increased faster than expected, but not uniformly. Density curves rose, fell, then rose again. Geological logic was replaced by noise. When Moscow demanded explanations, the team submitted cautious phrases. Heterogeneity of lower crustal composition, localized anomaly, possible in situ metamorphic zones. These were euphemisms for what we don't know. Funding committees insisted on coherence. Kola delivered madness. During December that year, one technician wrote in chalk on the operations board, "The deeper we go, the more surface we find." No one erased it. It summarized everything. Earth looping inward, folding knowledge back on itself. Scientists accustomed to crystal symmetry now face chaos patterns more fit for weather forecast than solid rock. They mapped uncertainty like explorers measuring fog. Even their most trusted instruments, seismographs, began misbehaving. Normally, drill vibrations travel cleanly. The returning echoes plot crisp spikes. But at 12 kilometers, the echoes thickened, blurred, split apart. Some came back early, some late, as if traveling along different routes through materials of inconsistent elasticity. Plotting them produced waveforms that resembled double exposures, two realities superimposed. The anomaly lacked cause until someone noticed faint magnetic variations along the same intervals. That correlation sparked new speculation, magnetic inclusions within the crust, ancient iron-rich bands twisted during formation, acting as invisible refractors for seismic energy. Whatever the explanation, it proved the planet was far more tangled than models allowed. A few nights later, an electrical storm swept the Arctic. Static charged the metal rig, making it hum audibly. In that eerie resonance, the ground itself seemed to answer, deep vibrations barely perceptible but measurable. Some joked the Earth was laughing at them. The monitoring printouts captured erratic spikes corresponding with lightning strikes miles away. It confirmed a terrifying detail. Even the atmosphere could influence readings at 12 kilometers. Nothing was isolated. Every system interfered with every other. The scientists realized they weren't simply drilling into matter. They were encountering a living network connecting air, rock, and heat. The Earth didn't sit silent waiting to be mapped. It reacted. Their instruments couldn't tell where cause ended and effect began. When pressure increased, temperature shifted. When temperature shifted, density changed, affecting pressure again. Loops within loops. The crust breathed mathematics that no computation could resolve. Years later, those same datasets would inspire computer simulations uncovering chaotic mantle convection, patterns that would never repeat yet never fully randomized. But in 1987, standing amid piles of half-functioning equipment, the researchers felt only defeat. Every graph whispered the same truth. The deeper they looked, the less they understood. In the final reports, an exhausted senior geologist wrote a single line that never reached publication. Beyond 11,000 meters, there exists a realm where observation collapses into confusion. He meant it literally. Past that depth, noise overwhelmed signal. The borehole had crossed from empirical science into philosophical territory. When the project finally paused that winter, the atmospheric Kola resembled that after a long argument with an unresponsive deity. They'd sought answers. The planet had given riddles. Among their last readings were seismic anomalies so erratic that computer algorithms flagged them as corruption errors. But the data wasn't corrupted. It was just honest chaos. One night before shutdown, the youngest technician stayed late at the console, replaying a day's worth of deep seismic logs. Out of static came faint rhythmic pulses, regular yet not mechanical, 6 beats, then silence, then 6 again. He woke the supervisor, convinced it meant something. But further checks revealed nothing. Instrument feedback, cross-phase interference, maybe coincidence. Still, the pattern haunted him. 6 beats, silence, 6. In later years, geophysicists reinterpreted that trace as evidence of mantle layering, zones where rock of different composition echoed at separate intervals. But at the time, it felt like nonsense codified into numbers, a heartbeat of the unknown recorded by accident. The mythic screams from hell had been mass hallucination born from heat and gas. The new mystery was quieter, colder, a whisper of physics refusing translation. If anyone asked what they'd learned from a decade of drilling, they no longer said crustal composition or geothermal gradient. The stock answer became a shrug followed by words everyone in Kola understood. The data stopped making sense. And maybe that was the real discovery, that beneath precision and pride, knowledge had boundaries shaped like shadows. The borehole had not reached hell, nor the mantle, nor glory. It had reached contradiction, pure and perfect. Humanity's deepest hole into Earth had become a mirror reflecting confusion back to the surface, a signal from below saying, in every language of numbers, that certainty ends 12 kilometers down. Section 8, The Collapse of Understanding. By the late 198s, the Soviet Union itself was fracturing, and the Kola Superdeep Borehole reflected that chaos perfectly. Funding evaporated, morale dissolved, and the drilling site, once hailed as the Soviet frontier of science, became an accidental metaphor for an empire boring into decay. Yet even as bureaucracy strangled the project, the true collapse wasn't political. It was intellectual. The deepest hole ever drilled had revealed something no ideology could digest, that everything we claimed to know about our planet was built on wishful geometry. When official reports came in from the last active months, they sounded almost like confessions. Internal memos described unforeseen compositional irregularities, polite phrasing for the realization that the crust was not a tidy gradient but a fragmented memory. Geochemists proposed that what lay beneath might be older than the surface itself, ancient relics of primordial rock preserved like fossils of time. The deeper data refused coherence. Temperatures climbed steeply, pressures defied scale, and core samples varied in silica content so radically that each layer looked like a separate planet. This contradiction sparked the MGC paradox, the strangest of them all. Analysts found the lower layers unnervingly rich in silica, opposite of what models demanded. According to decades of textbooks, the entire mantle should maintain a homogeneous ratio, one smooth chemical narrative from crust to core. Kola tore that story apart. If the samples were right, the lower mantle was not magnesium-dominated like expected, but leaned toward quartz-like composition, almost glassy in its chemistry. The numbers implied that Earth's interior had never mixed completely after formation. Beneath the known world might linger ancient chemical continents, unblended ever since the planet cooled. When word reached academic circles in Moscow and Leningrad, debates turned theological in tone. One camp insisted on measurement error. Another claimed heterogeneity was real, that silicate layers had segregated eons ago and persisted like ghosts of early Earth. Either possibility rewrote geology from its foundation. Around the same time, seismic tomography across the globe detected similar dense anomalies, zones where sound slowed inexplicably, deep within the mantle. Scientists began calling them LLSVPs, large, low shear velocity provinces. The correlation with Kola's eccentric readings was unnerving. Maybe the Soviets had drilled into the surface echo of those buried giants, unreachable bodies of ancient rock lodged miles deeper, defying convection's constant churn. That idea that the mantle might be layered, that regions could remain isolated for billions of years, meant one simple thing. The Earth's interior was not self-cleaning. History wasn't erased by heat and movement. It was preserved in secret. What the Kola team thought was a straight descent through well-mixed crust turned out to be archaeology on a planetary scale. Each kilometer broke through a new epoch, chemical relics unsmoothed by time. The planet was less a machine and more a museum spiraled inward. At the surface, though, none of this grandeur felt comforting. It felt like failure. Knowledge had stopped obeying mathematics, one memo lamented. The scientists weren't exaggerating. Their models for synthetic nanomaterial, pressure simulation cubes heated by lasers in Moscow couldn't reproduce Kola's findings. Sample densities disagreed. Mineral behavior under high stress failed to match prediction. Even equations describing how seismic waves travel through rock, the bedrock of earthquake science, now looked provisional. The deep Earth was no longer measurable. While the Soviet Union's ministries crumbled above, inside the Arctic facility, faith and science waned with startling speed. Instruments stood idle not for lack of electricity, but from the quiet understanding that more data meant more contradiction. The planet had turned from subject to opponent. Days felt heavier, the once bright steel rig now rusting under frost. Workers lingered in the canteen long after shifts, whispering that perhaps they'd hit the barrier between reason and madness. The phrase stuck, the horizon of comprehension. Yet some refused resignation. Geophysicists from the project convened one last symposium in Murmansk, presenting raw numbers that hinted at interconnected paradoxes. The MGC ratio ship linked with bigger mysteries, the unexplained density zones, the chemical fracturing, even the higher than predicted internal temperature. Taken together, they pointed toward a planet that was not a homogeneous sphere, but a stratified being, its inner self full of unmerged remnants. If true, that undermined almost every calculation of Earth's cooling, magnetic field stability, and tectonic evolution. In short, they hadn't just found anomalies, they'd found that our core story about the core was myth. Compounding the uncertainty was the inner core nucleation paradox, which dovetailed with Kola's outcomes. Around that time, theoretical models suggested Earth's solid core shouldn't exist under known conditions. Iron alone would remain liquid. The best explanations introduced lighter elements, carbon and oxygen perhaps, to lower the solidification threshold. It was another sign that previous certainties about composition were flawed. Kola's high hydrogen output meshed disturbingly well with this theory, hinting at deep chemical processes connecting surface and core through pathways no one had imagined. By 1991, as the Soviet flag lowered for the last time, the drill stood silent at 12,262 meters. The deeper goal, 15 kilometers, the Moho boundary, was abandoned. The hole was capped, its machinery dismantled or left to corrode. The research facility became a half-forgotten outpost at the edge of a disintegrating empire. But for the surviving scientists, the real loss wasn't financial. It was conceptual. They'd approached the project believing Earth would behave like a textbook cross-section. Crust, mantle, core, layered and predictable. Instead, they'd glimpsed a world both older and younger than reason, ancient in structure, youthfully volatile in behavior. A bipolar planet that refused classification. The collapse of understanding ran parallel to political collapse outside. Newspapers called the empire's disintegration entropy made visible. The scientists joked bitterly that the same description fit their data. The deeper they drilled, the less order existed. One of them wrote in a private notebook, perhaps systems, geological or political, share the same limit. Beyond a certain depth, complexity turns against itself. Even years later, researchers analyzing Kola's archive records admitted that some patterns remain unexplained. Temperature anomalies that surge irregularly, mineral assemblages inconsistent with any known pressure regime, phenomena still not reconciled with modern physics. Every attempt to remodel them leads to new variants of the same answer. The Earth's interior is heterogeneous, unstable, partially unmixed. In layman's terms, our planet remains unfinished. Standing by the sealed borehole today, you can feel that incompleteness. The site hums faintly with residual warmth, gas still venting in invisible sighs. Snow drifts around the metal cap like dust settling on a closed book. But beneath that welded lid sleep paradoxes that redefine geoscience, the silica-enriched mantle, the patchwork convection, the layered churning heart. Together they whisper one message: knowledge itself melts under pressure. The drill's final rotation wasn't just the end of an experiment, it was a requiem for certainty. The Earth had gazed back at its examiners and offered contradictions instead of clarity. Every discovery multiplied confusion, every answer branched into new doubts. The silence that followed the shutdown wasn't merely political, it was epistemological. For the first time, modern science confronted a riddle it couldn't outthink. Years after the USSR's fall, visiting scientists described the site as a monument to unanswered questions. They meant it kindly, because buried beneath 12 kilometers of mystery lay the real human story, not hubris or defeat, but the moment curiosity met its geological mirror and recognized itself, fragile, limited, and still reaching downward into the dark. Section 9, the lie we keep telling. The borehole might have stopped at 12 kilometers, but the story people told about it didn't. In brochures, in documentaries, even in textbooks, the Kola Superdeep became shorthand for the limits of technology. That's the official version. We dug as deep as tools and budget allowed, found nothing mystical, then moved on. It's neat, tidy, and comfortable, exactly the kind of story humans build when mystery starts to itch. But standing near that sealed cap, surrounded by Arctic silence, another idea lingers. The real limit wasn't heat or pressure or money. The real limit was knowledge itself. Look, there's something we do every time we reach a frontier. We adjust the narrative so the unknown sounds like a choice. We tell ourselves we could have gone further if we wanted, and we turn back because it was impractical, not impossible. It's easier to close the book that way. We said it about the oceans, about space, and eventually about the Earth's own crust. But deep inside, everyone who ever worked at Kola knew the truth. The planet stopped yielding because it wanted to, and we stopped asking why because we couldn't stand the thought that curiosity might have boundaries. The public version painted a story of triumph ending gracefully. Official communiques framed it as the completion of an experiment. Yet the raw data hinted at something else, an encounter with contradictions so severe that even language faltered. How do you tell people the ground beneath their feet isn't stable in theory or fact? That the maps in geology classrooms are convenient sketches drawn over chaos? It's easy to keep repeating a smaller lie, the one that says we understand where we live. The lie isn't malicious, it's protective. Civilization leans on predictability. We build cities, plan roads, calculate earthquakes, trusting that the rules of Crust and Mantle obey our formulas. If we admitted that basic assumptions crumble 12 kilometers down, public confidence in reason itself might follow. So we nod, file the reports, and carry on calling uncertainty anomaly. The lie keeps the lights on. Maybe that's why the myth of screams from hell survived long after sound science disproved it. In a strange way, the myth and the metaphor serve the same purpose, to give shape to what we can't explain. The tabloid story framed the unknown as divine punishment. The modern story frames it as technical limitation. Both fill the silence with something manageable. Neither faces the core truth that between our understanding and Earth's reality lies a gap we can't bridge with equations or microphones. Every civilization through history has its version of that gap. Some called it the underworld, others the abyss, others still the place where knowledge melts. The Soviets called it a borehole. What they found down there wasn't a destination but a mirror. It showed our hunger to know colliding head-on with the planet's indifference. We learned that the ground itself keeps secrets the way the sky keeps distance, endlessly. The irony? We celebrate mastery exactly because we rarely achieve it. We tell ourselves the world is mapped, measured, conquered. But each discovery hides another recess that refuses translation. The Kola project just made that refusal visible. After all the equations and drills, the Earth reminded us we're intruders in a conversation that started billions of years before thought existed. That's the lie in the title, the quiet comfort that science hasn't handled. We trace cross-sections of the mantle as if they were anatomy diagrams, forgetting their guesses resting on hearsay vibrations. We plug numbers into models built on wishful symmetry and call it understanding. But at 12 kilometers, the graphs bend, the heat mutinies, and the neat lines dissolve. What's under our feet is an active question disguised as rock. When you think about it, the Kola Borehole ended the same way most great explorations do, with silence mistaken for conclusion. The last engineers welded the lid, walked away, and wrote reports summarizing uncertainty as success. From orbit, humans kept going upward. Satellites, probes, telescopes, because looking down had proven too strange. Maybe that's our default instinct. If the darkness below rattles the mind, aim for a different kind above. And here's the twist that haunts every scientist who's ever studied Kola's archives. We didn't lose to ignorance. We lost to the illusion of understanding. The moment we believed the planet was fully charted, curiosity became arrogance. That arrogance cracked under pressure, just like the drill bits at the bottom of the shaft. The lie isn't that the hole failed. It's that we ever thought it could succeed by force of will alone. Yet maybe that's part of being human. We chase answers knowing they'll evaporate at the finish line. We lace instruments with hope even after they've melted. We tell ourselves we've reached the core when all we've done is bruise the crust. It's not deception in the cruel sense, it's survival through story. Without that story, we'd have to face an unbearable equation that the closer we get to truth, the less it behaves. So when people visit the Kola site today, they read the plaque, glance at the concrete plug, maybe smile at the absurd myth of hell beneath Russia, and move on. But somewhere below them lies the boundary between comprehension and chaos, the place where science itself looked down and blinked. The lie we keep telling isn't just about depth. It's the whisper that says knowing will one day be complete. The real answer, sealed 12 kilometers beneath a frozen plain, is simpler and far stranger. Understanding has layers, not limits. Peel one back and there's always another, warmer, harder, less interested in being known. That's why the world's deepest hole feels endless even at 12,000 meters. It's not the distance that matters, it's what it represents. A reminder that beneath every certainty, the Earth is still writing secrets in heat, rock, and silence, and we are still inventing stories to pretend we're keeping up. Section 10. The Endless Unknown. Every empire leaves a scar that never quite heals. For the Soviets, it wasn't Chernobyl, the vanished statues. It was a hole, a wound drilled into the Arctic crust and sealed before it could reach its goal. The Kola Superdeep still sits there today, hidden among patches of snow and rusting towers, its 12-kilometer throat closed with welded steel. Nothing grows around it except lichen and rumor. The landscape feels haunted not by ghosts, but by unfinished questions. That's the strange thing about the unknown. Once you touch it, it keeps touching back. Look at modern science trying to fill that silence. Decades later, engineers in Japan built the Chikyu, a gleaming white chip aimed at doing what Kola couldn't, pierce oceanic crust thin enough to reach the mantle. Its drills descended through miles of seawater and basalt before stalling. High-pressure crushed joints, heat-scrambled sensors, and in the end, a C1. Germany followed with the KTB project, boring 9,000 meters into Bavarian rock. Same story. Temperatures climbed beyond tolerance, cores warped under stress, and the drillers stared at glowing bits thinking, haven't we seen this before? Every generation announces a new solution. Diamond-tipped drills that slice through granite like butter, laser-assisted boring melting rock into glass, AI-controlled rigs learning from vibration in real time. On PowerPoint slides, they look unstoppable. In reality, all of them stop where Kola stopped, around the point where a rock turns to confession and starts devouring the tools meant to study it. Even our most advanced prototypes can't last in that furnace of pressure and temperature. The deeper we try to go, the faster the Earth chews through ambition. Still, humans keep returning to the idea of a second descent. Universities file patents for plasma drilling. Startups boast about reaching the mantle for geothermal power. Investors love the narrative. Infinite clean energy hiding under our feet. But old data from Kola whispers a warning. The rocks don't behave. Down there, matter rearranges itself faster than humans can model it. The line between solid and liquid blurs, and information turns liquid too. That's the physics nobody wants in a pitch deck. The deeper you look, the less meaning survives. If you walk near the borehole today, you can hear it breathe. Not loudly, just a faint metallic sigh as trapped hydrogen escapes through microscopic cracks. In winter, that gas freezes the frost rings around the cap, glowing faintly in moonlight. It's easy to imagine the hole alive, exhaling the last sentences of an unfinished conversation. Officially, it's inert. Unofficially, it's still busy proving that silence can teach louder than noise. Tourists visit sometimes. They take selfies beside the corroded lid and post captions like the gate to hell, unaware of how close the metaphor truly cuts. Kola isn't hell, it's humility sculpted in steel. It's the place where curiosity hit a thermal wall and bounced back like sonar against the abyss. Scientists who work there say that standing near feels like standing beside time itself, that even the wind hesitates before crossing the borehole's shadow. The Arctic sun circles but never rises high enough to warm it. Isn't that fitting? Our greatest monuments aren't the towers we build upward, but the holes we fail to finish. The pyramids point skyward proclaiming certainty. Kola points inward admitting defeat. Yet that defeat glows with something uncanny, awe. Because underneath all the supercomputers, alloys, and equations lies the one emotion that built civilization, wonder mixed with stubbornness. We dig knowing we'll lose because losing feels closer to truth than staying on the surface. In the years since the lid cooled, satellites have mapped the planet's magnetic field, rovers have sampled Martian dust, and telescopes have seen galaxies from when the universe was newborn. Yet none of those revelations feel as intimate or as disquieting as standing above a hole 12 kilometers deep that leads nowhere we can go. Looking out into space gives perspective. Looking down into Earth gives vertigo. The first expands you, the second exposes you. So when people say, we've explored everything, they forget this quiet monument. The deepest hole we ever dug remains shallow compared to the distance between knowledge and ignorance. That's why the Kola site endures. Not as evidence of failure, but as proof that mystery is the engine, not the obstacle. Each failed project is another orbit around the same truth. The planet doesn't yield its heart to measurement, only to patience. Sometimes late at night, Arctic researchers camping nearby report faint warmth under their boots, a pulse of heat that travels upward from below the permafrost. It's probably residual thermal expansion pushing through the seams, but no one quite knows. The readings drift, instruments overheat, and eventually everyone stops asking. It's easier to let the Earth keep a few secrets. The infinite isn't above us, it's under us, compressed into silence. Kola's steel lid is just humanity's bookmark in that unread chapter. Modern thinkers dream of breaking it open again, not for glory, but for curiosity so ancient it doesn't need results, only the act of asking. That impulse, the same one that built the first fires and sent rockets skyward, is what hums beneath the frost where the rig once stood. It's the proof that we're still listening for the planet's answer. Maybe one day a new technology will survive the 300-degree inferno and slip past 12 kilometers into whatever secrets lie beyond. Maybe it'll collapse a meter deeper than Kola and dissolve like all the rest. Either outcome fits the pattern. Because the story was never about reaching the mantle, it was about remembering that some boundaries are invitations, not walls. So the hole stays sealed, breathing quietly under the northern sky, a frozen monument to unfinished understanding. It doesn't beg to be reopened, only remembered. The scientists called it a failure. History calls it a landmark. But the Earth, if it could speak, would call it what it's always been, a question with no bottom. The edge of knowing. They say if you press your ear to the steel lid on the Kola site, you can still hear it hum. It's not true, of course, not in the way myths demand. What you hear is the Arctic wind brushing across metal warmed by the Earth's breath. But listen long enough and it starts to sound like something else, the echo of a question we never finished asking. For decades, it's been sealed beneath frost and secrecy, a monument to that moment when humanity reached the edge of its own logic and stared down into silence. Those screams from hell that terrified radio listeners weren't proof of the supernatural. They were the world's oldest sound, the vibration of stone expanding under heat, the planet sighing through its fractures. The noise we feared was just the sound of our own curiosity meeting resistance. Every rumor since then, every exaggerated headline is really the same story retold for comfort. We heard something down there we couldn't name, so we invented voices to fill the void. But what Kola truly recorded wasn't horror. It was the sound of Earth reminding us that knowledge has limits drawn in temperature, time, and patience. Standing above that site today, you realize the true abyss was never underground. It's the invisible chasm between what we observe and what we understand. We've crossed it in so many directions: spaceflight, quantum science, genetics, and each time the same lesson waits on the far side. The more light we cast, the longer the shadows grow. Kola just phrased that lesson as geology. 12 kilometers down, we hit the threshold where human comprehension turns molten. Maybe that's why the hole feels sacred. Not because it hides something divine, but because it exposes how fragile knowing really is. We still chase new depths, under oceans, into atoms, across galaxies, but every pursuit circles back to this quiet Arctic wound. It isn't failure, it's our reflection. So if you ever find yourself near Zapolyarny, pause beside that rusted tower and listen. The hum beneath your feet isn't screaming, it's invitation. The deepest hole we can't dig isn't in the ground at all. It's the one inside certainty. If you want to see how far that mystery still goes, stay curious and keep